Okay, let us start today's lesson. Okay, so I will go to the textbook. Okay, so continue from previous lesson. Okay, making relation between the vertex form of a quadratic functions, okay, in this form with the others form of a quadratic functions. Okay, so what's the index for today? Yeah? Okay, a relation between the vertex form with other forms. Okay, so this is the index for today. Okay, today is what? 11. Okay, so you still use your MS2. Okay, let us see this. Okay, so quadratic functions we have three types of not to say three types, three forms, okay, of quadratic functions. Okay, so one is vertex forms. This is vertex form. Okay, this is vertex form, and then general form, that one you know. Okay, and then one more is we call it intercept form. Okay, this one we will learn afterwards. Okay, so there is three forms of quadratic functions. Okay, the diagram on the right show the sketch of the graph of a quadratic function in vertex form. Okay, this is the in vertex form. Since a is positive, okay, smiling face. The graph of the quadratic function is in the shape of the U. Okay, note that the graph of this quadratic function has its vertex at the minimum point 2, -9, and the equations of the axis of symmetry is x equals to 2. Minimum point, because smiling face, minimum point, and then this is a point. Okay, you have to know this is always they will come out in paper 1. Okay, minor things all this okay, they will give you this. Okay, from here, okay, you can know what is the minimum or the maximum point, and then also what is the axis of symmetry. Axis of symmetry. Okay, so this is how we get the maximum or minimum point. Okay, this one will be the y coordinate. The y coordinate, okay, of your maximum or the minimum point. Okay, then this one, let it equal to 0. X minus 2 equal to 0, then x is 2. This one will be your x coordinate, okay, of the maximum or the minimum point. Okay, therefore you see 2, -9. 2, -9. Okay, in this shape is a smiling face, so it's minimum point. Okay, minimum point here. Okay, therefore axis of symmetry, we take the x coordinate for the minimum or maximum point. Okay, x equals to 2. This one will be the axis of symmetry. Okay, axis of symmetry. Okay, so when you have an in vertex form, it's very fast. You can analyze what is the maximum or minimum point and what is the axis of symmetry. This is the advantage, okay, of a quadratic function in vertex form compared to the general form and compared to the intercept form. Okay. Okay, so the vertex form of a quadratic function in the form of this, where a, h, and k are constant, the vertex is hk, and it is symmetry about the line of x equal to h. Okay, when a is positive, the vertex hk is the minimum point, and k is the minimum value of the fx. K is the minimum value. Okay, you look at this graph. Okay, you look at this graph. Okay, what is the minimum value of this graph? This value will be the minimum value of this graph. Means there is no more value that less than this. Okay, so -9 will be the minimum value of this fx. Okay, fx actually is y ma. Okay, so what is the minimum value of the y? So -9. Okay, so when a is negative, then the other way around. Okay, will be maximum value. Okay, so we continue. Okay, now we look at this the other form. Other than the vertex form, the quadratic function can be written in the following form. Okay, form of quadratic functions. So the other form will be general form. Okay, this one you are familiar with it, general form. Okay, always we'll deal with general form. Okay, where A, B, and the C are constant. Okay, with a vertex. When you see in general form, you want to find the vertex, it's not that easy. Okay, you can memorize this. Okay, you just memorize this part. Okay, how to get the x coordinate. Okay, then when you get the x coordinate already, you just substitute back into these functions, then to get the y coordinate. Okay, that's why if you want to memorize, you just remember this negative b over 2a. Okay, if not, then you just have to change the general form into a vertex form, and then from there you analyze the maximum or minimum point. Okay, then you see the symmetry, the axis of symmetry is this. Okay, same thing. You just need to know the x coordinate of your maximum or minimum point. Okay, so if you want to memorize, or you need to memorize, you just memorize this. If you don't want to change it into vertex form, sorry. Okay, second one, intercept form. Okay, intercept form, okay, the functions it will give you in this way. Means from here very fast you will know, okay, the P and the Q are the two roots, okay, are the intercept point, or the x-intercept, okay, for the fx. Okay, means this way. Example, okay, smiling face, let's say, so this one will be the P and this one will be the Q. This is a meaning. Okay, this is x-axis. Okay, x-intercept. Okay. It can be P on the right hand side and the Q on the left hand side. Okay, either one. Okay, A, P, and Q are constant. P and Q are the roots or the x-intercept for fx. Okay, its vertex is at this point. Okay. This one is easier to remember. Okay, why? Because you know, the shape of the quadratic function is a parabola. Okay, and then it's a symmetry. Therefore, you want to get this point, which is this point actually. Okay, the x coordinate here. So you just get the midpoint of a P and Q. That's why you see it's P plus Q divided by 2. This one easier to memorize. Okay, than this one, negative b over 2a. Okay, so this one, same thing, the axis of symmetry, okay, will be the x coordinate for the minimum or the maximum point. Okay, this one. Okay, so after that, we need to learn, you know, how to change in between from these three forms of the quadratic equations. Okay. Okay, so that's all for this. We continue. This one I will skip. Okay, now we come to this. Okay, this one you can copy this also. Okay, you know, when change in between each form, okay, what you have to do actually. Okay, so in expressing a quadratic function in vertex form to general form and intercept form, or vice versa, the following methods can be used. Okay, so you see, okay, so you see from vertex form, okay, actually vertex form, you notice that or not, this is completing the square. Okay, if you do completing the square, you will getting this. Therefore, you see from general form to a vertex form, you are doing completing the square. Okay. So from vertex form, go back to general form. Okay, you just do expansion. Okay, then from general form, you go to intercept form, you do factorization. Okay, then from the intercept form, okay, come back to general form. Okay, you do expansion. So you see, anything want to go back to general form, you just expand. Okay, means got no bracket anymore, so you do expansion. And anything you want to go back to general form. Okay, so we will see some example. Okay, look at example 12. How's my attendance now? 28 still. Someone can call Pei Chi. And I don't know who is the one more. Monitor. Again, I forgot already who is the monitor. Who is the monitor or assistant monitor? Monitor, assistant monitor? Anyone? Okay. Valerie, huh? Okay, Itasha, sorry. Can you go through the list? I don't know who is the one or one more that not here. Valerie, you know who is not here or not? Okay, and then can someone call Pechi? Okay, so I'll continue my example. Okay. Mhm. Okay, go through example 12. Okay, you see example 12. Okay, this one is in vertex form. Okay, from vertex form want to go to intersect form. Let me go back to this. So from the vertex form you want to go to an intersect form. First, you have to go through the general form, only go to intersect form. You can't straight away jump from a vertex form to intersect form. No way. Okay, so from vertex form, you want to make it general form, you have to do expansion. Then after that, from general form, go to intersect form, you do a factorization. Okay, so we go back to this. So expansion, after that, factorization. Okay, so we see this example. Okay, first of all, we do expansion. Okay, here they do expansion. Okay, after that, bring in the 2. Okay, then combine the constant terms. Okay, then you get this. This one is in general form. Okay, after that, from this general form, you do factorization. Okay, so this is intersect form. Okay, you cannot just stop here. You cannot just stop here. You got to continue this is because, okay, let us see the intersect form. Okay, intersect form here, for the x here in front is 1. Cannot be other things. And then it's positive. Okay, so any other thing you got to factor out. That's why you have an A here. Okay, let us come back here. Okay, you see this? This is 1x, okay? This is good. Okay, but this is 2x. This is not good. Therefore, the 2, I got to factor out. Okay, means this one I divide by 2. This one I divide by 2. So I got x plus 5 over 2. Then the 2 is outside. Okay, this is how you factor out the whatever you don't want for the coefficient for the x. Okay, so this is intersect form. This one only is a complete intersect form. Okay, then after that do what? Okay, where A, P, and the Q are the constant. Okay, P is smaller than Q. Okay, state the value of A, P, and the Q. Okay, so you have a 2 value here you have a 5 over 2 and 2 Okay, they want the P is smaller, so 5 over 2 is what? 2.5 Okay, so P is 2 lor. P is 2. Oh, no, sorry. Okay, you got to compare. Okay, compare with this. Okay, I write here 2 plus 5 over 2. Okay, 2. Okay, therefore A is 2. Okay, A is 2. Then this is this. I don't know which one is bigger. Correct or not? Correct? Okay, so you see negative P is equal to positive 5 over 2. Therefore, P is negative 5 over 2. Okay, P is negative 5 over 2. Be careful with the sign. Okay, then this one also same thing. Okay, negative Q is 2. Therefore, Q is negative 2. Okay, okay, just be aware of the sign. Okay, and then this one actually is a question. Do you agree with this statement? Actually is you have to agree this is correct statement. Okay, so you may copy this. Okay, not all the vertex form or general form can be expressed in intersect form. Okay, only graph which have x-intercept can be expressed. Okay, if got no x-intercept, actually they can't do factorization. Okay, they can't do factorization, then they cannot express in this how to say intercept form. Okay, so this one means like that, only this type of graph. Okay, only this type of graph, or maybe this also can, maybe this also can. 1 point, they still have a x-intercept, means the P and the Q are the same maybe. Okay, when we come across to this type of questions, but this bear in mind, not all the vertex form or general form can be expressed in intercept form. Okay, so only graph which have x-intercept can be expressed. Okay, so means this type of graph, there's no x-intercept, though this one got no intercept form. No intercept form. Okay. Okay. Okay, this is another alternative methods, alternative methods for these questions. Okay, but you see, it's more complicated, lor. Okay, this one they skip the general form. Okay, from the vertex form. Okay, direct. Okay, you get the intercept form. Okay, so first of all, you must express this one. Okay, 1/8. How? A bit complicated. Can you see this? Actually, this one I leave it to you. Okay, I leave it to you. You see by yourself. Here they factor out the 2. Here they factor out the 2. Okay, and then they write this as a 1/4. Okay, the whole thing power 2. Therefore, then they use a squared minus b squared is equal to a plus b, a minus b. Okay, then they write in this way. So this is the a plus b, and this is the a minus b. Okay, here is the a squared minus b squared. Okay, then after that they just combine the constant term, they combine the constant terms. Okay, then they just okay, make sure this is our coefficient for x is 1. Yeah, correct. Okay, then just simplify, then they get the answer. Okay, but if you feel this way is more complicated, then just forget about it. Okay, this is just extra knowledge for you. Okay, now we go to another example. Okay, example 13. Okay, express this. This is in general form. Okay, as this. So this is in vertex form. Okay, so just now as I say just now, general form to vertex form is using or completing the square. Okay, same thing, you got to determine the value of the a, h, and the k. Okay, so now we continue. Okay, so this is in general form. Okay, so first thing, make sure the coefficient of the x square is 1 before completing the square. Okay, so how you want to make sure the coefficient for x square is 1? Okay, by factor out the -3, no? Okay, by factor out the -3 means you divide every term by -3, divide by -3, divide by -3. Therefore, this one you get 1. This one you get -2/3. This one you get -1/3. Okay, this is how you get this. Okay, when you factor out -3 outside. Okay, factor -3 from this. Okay, then next step. Okay, you still remember negative b over b over 2 the whole thing squared. Okay, plus and minus. Yeah, so here you see the b here is this. The b here is this. So negative b over 2, so negative 3/2 over 2. Sorry, negative 2/3/2. Okay, this one is equals to I think I go through this one with you already. I hope that you can do it very fast. Okay, so -1/3. Okay, so you get a -1/3 here. This is why you get negative 1 over 3 here. It's come from the b over 2. Okay, so remember it's plus b over 2 the whole thing squared minus b over 2 the whole thing squared. Okay, and then the negative 1 over 3 is from here, the originally one. Okay, so add and subtract coefficient for the x, which is a b over 2 the whole thing squared. Okay, so done this part. Okay, therefore the next one, when you write out this bracket, okay, is take from here the x and take from here negative 1 over 3. So x minus 1 over 3 and then square. And then this one continue. Okay, then this one combine. You get this. Okay, last step, bring back the negative 3 here and here. Must bring back. Not bring back, then you can't get the exactly the same like this form. You can't get this. Okay, so 1 over negative 3 bring back here, but not inside here, not inside here. Okay, just outside of this, just here, outside for this only. Okay, so it's negative 3, then the bracket, then square, and then negative 3 times negative 4 over 9, you get positive 4 over 3. Okay, so now it's already in vertex form. Let us compare. Okay, a x minus h and then squared and then plus k. Okay, this sign is very important. This sign, sometimes they write minus, sometimes they write plus. I also don't know. Okay, but some they make mistake, but some they don't make mistake. Okay, so you just be aware of this sign. Okay, so therefore you compare. Sorry, the a is negative 3. Okay, a is negative 3, then x is x. Okay, then minus is minus. Therefore, you straight away compare. H is 1 over 3. H is 1 over 3. Then k is 4 over 3. K is 4 over 3. Okay, let us do this. Okay, because you're having a new syllabus, we don't know the questions. How difficult is your questions, okay? So all this, whatever I can, I try to show you, Okay, by using completing the square method, show that the equations of the axis of symmetry for this. So this is general form. So general form, I go into do completing the square. Okay, so after that I will get the axis of symmetry, which is actually the h lah. Okay, is this. Okay, so now I'm going to do using another page. Okay, I start with this. Okay, general form. Okay, so do completing the square. Okay, so first I have to make sure the coefficient for x squared is 1, right? So I got to factor out a. Therefore, the meaning is I divide all this by a. So the first term will become x squared, second term b over a. Then the third term c over a. Okay, after that, okay, b over a is the coefficients, new coefficients for the x. Okay, so remember I need the coefficient for the x, which is b over a over 2. Okay, then whole thing squared. Okay, plus and minus this. So this one will become b over 2a squared. Okay, so I'm going to do plus this minus this and then plus c over a. Okay, next I'm going to write out the brackets. Okay, from here and from here. So it's x plus b over 2a and then squared. Okay, then I got to expand this and combine this. Okay, negative b squared 4a squared. Okay, I bring in the square for every terms. Okay, plus c over a. Okay, I'm not sure whether I can combine these two. Okay, but I think I will just leave it first. Okay, so next I will bring in the A. Bring in the A. Okay, for this. Okay, so A, B over 2A. Actually, I can see the answer already. Okay, when the A for A, when the A time with this, let's see. Okay, so when you compare with the what to say? Vertex form. Let us compare with the vertex form. Okay, the axis of symmetry of the vertex form is here. Is this. Okay, therefore, you see, negative H is this. Okay, negative H is this. Therefore, H is negative B over 2A. Okay, so this is the axis of symmetry. Okay, so it's proven now. So we come back to the textbook. Okay, here have a homework for you. Okay, before that, how have I all attendance, full attendance? Pechi here already. One more. Who is the one more? Itasha, do you know who is the one more? Pechi, Pechi. Why you come late? Iris, what happened to her, Itasha? Someone can contact her? Iris Wong, is it? Not sure. Anyone can contact her? Who is a good friend of Iris in this class? Pechi, answer me, Pechi.
I overslept.
Hmm? Yes?
I overslept.
Oh,
Sorry.
okay. Pechi, you didn't hand in homework, you know?
Huh?
You didn't hand in homework, is it? I can't find your homework in the Teams the general post.
Oh, I didn't know.
You didn't know. Why
I
you always didn't know? Always check lah. Okay, after handing,
yeah.
okay, so who is a good friend of Iris? Teacher, I call her already. Okay, then. She didn't pick up, Aiyo. Okay. Mm-hmm. Mm-hmm. Okay lah, never mind lah. We continue lah, So after tell her to watch the recording, and then do the homework. Okay, we come back to this. Okay, let me see. Okay, I want to, okay, this is your homework today. I just want to draw your attention here. Okay, so you see, always the vertex form, this is minus, but here is plus. So you got to be careful lah. Okay, sometimes they give minus, sometimes they give plus. Here the same thing. Okay, so also they give plus. Okay, so this one actually is this way, same lah. You just set this. You know, just now beginning, how you get the point? You just set this. Okay, therefore x is equal to h. Okay, so you from here, what is the x coordinate for the maximum or the minimum point? Okay, here is maximum point lah. So what is the x coordinate for the maximum point? Okay, -2 lor. Okay, therefore, okay, negative h is equal to -2. So your h is 2. So be careful with the sign given, Okay, sometimes they give you a plus, sometimes they give you minus. And then this one the same thing. Okay, and then one more is these two questions. These two questions we didn't try before, huh? Okay, but I just want to go through with you. This is intercept form. Okay, from the intercept form, we want to go to vertex form. So same thing, you must go through general form first. Okay, so when go to general form is by expansion, and then when from general form go to vertex form is by completing the square. Okay, so remember these two must go through a general form first, even though I didn't give you one example lah. Okay, so I think I still got time to go through one more. Okay. Okay, this one is almost the same like that day, you know. We analyze the A and the B and the C, you know, the changes of the A, B, and the C, how it will affect the shape of the graph and the position of the graph. But that day is on general form. So today is in on vertex form. So we want to analyze the effect of the change of the normal ABC, but here is A, H, and the K. Okay, on the shape and the position of the graph lah. Okay, so today's one we want to see in a vertex form. Therefore, you have a H, and a K. Now you see here is minus. Here, very confusing, that's why. Okay, this one change to minus. Okay, the quadratic function in the vertex form. Okay, A, H, K are constant. Vertex is at HK. Therefore, this one is confirmed is negative because when x minus h is equal to 0, x equals to h. This is positive. This is positive. Okay, so this one changed to negative. And is symmetry about the line x equals to h. What will happen to the shape at the position of the graph of function f(x) when the value a, h, and k are changed? Okay, so I will go through with you this website. Correct, meh? Why you link me to like that day one more? This is A, B, C. But here is in general form. Okay, if I follow the textbook, it say that A is at 2, H is 3. H is 3 means 3, 1 is the 3, 1 is the minimum point. 3, 1, no leh. Apa macam? How to something wrong, oh? Correct, right? Just now I type. Here they write in apa tu vertex form, but here they write A, B, C. Then I got no slide of the A, H, and the K. That's why sometimes. Okay, one more time I try. Then we just I just explain to you lah, verbally lah. This is 2O R N S. Still the same thing I think. Okay. So, tak boleh pakai. Okay, tak boleh pakai then. Nothing already lor. Okay, we go back to the textbook lor. Just chalk and talk lor. Okay, so this one. Okay. If the software can show you how you will can see lah okay, what will happen to the graph. Okay, so this one you have to copy okay. You no need you can choose to don't copy exactly. You can make your own notes. Okay. Okay, let us start with A. Only the value of the A change. Okay, this A actually same as the A in the general form. Okay, at the page 50. Okay, I make a short note here. Same as the A in general form. Okay, at page 50. Okay, if you the previous one okay. So change in the value A affects the shape and the width of the graph. You still remember? Okay, in general form the same thing okay. So when A is positive, so this one is the same. Okay, U shape or smiling face passing to minimum point. Okay, negative then is a N shape. Okay, or the sad face it passing to maximum point. Okay, then for A is positive. Okay, then the A increase. Okay, the width of the graph decreases, means become thin. Okay, then conversely when the A decreases, okay, approaches to 0, okay, the width of the graph increases. Okay, then for the A negative, okay, A is decreases to the smaller than negative 2, the width decreases. Okay, then A increases, approaches to 0, the width increases. Then the axis of symmetry, the maximum minimum value all remain unchanged. Okay, so now we go to the H. Okay, what is the H? Okay, H actually is the x coordinate of the vertex. Okay, H is x coordinates of the vertex. Vertex means the maximum or the minimum point Okay, so if H change, mean the x coordinate of the vertex also will change Okay, that's simple. Okay, so the change in the value of H only shown the horizontal movement of the graph. Okay, when the value of the H increases, the graph will move to the right. Okay, whereas when the H decreases, the graph will move to the left. Actually, the H is the position of the axis of symmetry changes, but the minimum or the maximum value remain unchanged. Okay, the positions of the axis of symmetry changes. Okay, but the minimum or maximum value remain unchanged. What's the meaning? Minimum, maximum value remain unchanged. Okay, so means this way. If you have graph this way, okay, then when you change the H, so how do I mark? Okay, let's say, okay, let's say here is 5 lah Okay, so the minimum value is 5. When you change the H, okay, you will just move this way. The minimum value is still remain is 5. Okay, something like this. Okay. So the last one ready. Okay, only the value of the K changes. Okay, the value of the K is what? The value of the K is the maximum minimum value or the Y coordinate of the vertex. Okay, K is the Y coordinates of the vertex. So the whole graph will move up or down. The change in the value of K only show vertical movement of the graph. When the value of K increases, the graph will move upwards. Okay, whereas the value of K decreases, the graph will move downwards. Okay, so the maximum and minimum value change, but the axis of symmetry remain unchanged. Okay, this is the meaning. Okay, if you have graph, okay, this is the axis of symmetry. Okay, if you change the value of the K, okay, maybe decreases. Okay, the axis of symmetry is still the same. Okay, this is the meaning. So actually not that difficult. Okay, we look at this example. I'm not sure, maybe I can use one software to show you. Okay, but we go through first lah, huh? The diagram on the right show the graph. Okay, fx equal to 2 in bracket x plus 2, okay, square and then plus 3, where a is 2, h is negative 2, and then k is 3. Make generalization on the effect of change in each of following values on the shape and the position of the graph. Okay, the value of a changed to 6. Okay, from 2 change to 6. Okay, so it becomes thinner. Okay, from 2, the 2 is the dotted one. Okay, change to 6. Okay, the red color one. Okay, so it becomes thinner. Okay, so you got to make a generalizations. So you got to talk. Okay, other than you show it on the graph. Okay, two graph, both graph. Okay, then but you still have to say, okay, what? Okay, when a changes from 2 to 6, the width of the graph decreases. The axis of symmetry and the minimum value remain unchanged. Okay, then okay, a change to a half means from 2 change to half. Okay, so from 2 change to half, so you see the width become bigger. Okay, so from a, when a changes from 2 to half, the width of the graph increases. Okay, the axis of symmetry and the minimum value remain unchanged. Okay, so same thing, you got to show the two graphs, okay, to show the difference. So the dotted one is the original one. Okay, then the how to say is a thinner one. Okay, then when a change to half, okay, become wider. Okay, next question B, the value of the h changes to -6. From what change to -6? From -2 change to -6. Okay, we'll see what will happen. From -2 change to -6. Okay, so this is from -2, okay, -2, and then change to -6. Okay, so it just moved to the left. Okay, so how you explain it? When h changes from -2 to -6, the graph with the same shape move horizontally 4 units to the left. You see, same shape, move horizontally. Okay, 4 units to the left. Okay, all these are keywords. Okay, the equations of the axis of symmetry become x equals to -6. Okay, you can mention, okay, axis of symmetry become this, and then the minimum value remain unchanged, that is 3. Okay, so this one also you got to mention. Okay, now we go to part C. Okay, part C, the value of k changes to 8. Okay, the value of k changes to 8. Okay, value of k changes to 8. Okay, the value of k originally is at 3. 3 change to 8. Okay, you move upward. Okay, from the 3 move to the 8. Okay, for the vertex. Okay, when k changes from 3 to 8, the graph with the same shape move vertically. Okay, how many units? 5 units upwards. Okay, upwards or downwards. Here is upwards. Okay, the minimum value become 8. The equations of the axis of symmetry still the same. Okay, this is how you explain. Okay, so this is another homework. Okay, maybe I help you a little bit. Okay, maybe I help you this. Okay, look at this. Determine the coordinate of the maximum point. Okay, and the equation of the axis of symmetry. You see, this is a very common questions. Okay, so maximum point, you're getting from here and here. Okay, so here will give you the x coordinate. Okay, so you let x minus 2 equal to 0, so x is 2. Okay, then this one will give you the y coordinate. So your maximum point will be 2, 4. Okay, if they didn't give you the graph they give you the graph, actually very simple, you just see from the graph. Okay, then equation of the axis of symmetry is this line. Okay, this line, the name is called x equals to 2. Okay, because any point that fall on this line, the x coordinate is 2. That's why this line named as x equals 2. Okay. The part B, then you do like the example, huh? Okay. This one also, I will help you with this maybe. Okay, state the value of the H, K, and the P. H, K, and the P. H, K, and the P. Okay, this is in how to say? Vertex form. Okay, now vertex form. Okay, how do you compare with this? How do you compare with this? Okay, the H is this. Okay, x minus 3 equals to 0, x equal to 3. Okay, the 3 is the H. Therefore, H is 3, the first one. Okay, usually if this type of question come out in the exam, this is only 1 mark here. No working got no mark lah, but you just show. Okay, then this is this. Okay, therefore 2k equals to -6, then k is equal to -3, and another mark. Okay, then last, where is the p? Oh, p is here, sorry, p is here. Okay, p is the how to say, the y-intercept. So you want to find y-intercept, you got to let x equals 0. Okay, when x equals 0, okay, then what will happen? 0 minus 3. Okay, now 2k is the -6, so -6. Okay, so this is 9 minus 6, so is 3. Okay, therefore p is 3. P is 3. Okay, so here maybe they will give 2 marks. Okay, so I have helped you for this. Okay. Next, okay, look at number 3. Compare the graph of each offering quadratic function to this graph. Okay, with each vertex as 0, 0. Okay, this graph, how to say, this is in a vertex form, yeah, vertex form. Okay, you want to compare with this, but this one looks so empty. What is the A, what is the H, and what is the K here? Okay, this one look like not like a vertex form, but actually is a vertex form also lah, because this one got no only got A, got no B and the C. Okay, if this is in general form. So how you going to write this in the vertex form? Okay, so that you know what is the A, what is the H, and what is the K. So when you compare with this and this, you know what to compare lor. Okay, whether you know the A increase, the H or the K increase or decreases. Okay, so how? Okay, we compare with the vertex form. Okay, vertex form is this way. Okay, so in this case, okay, the A will be 1, no? Okay, and then the H is 0, and then also K is 0. Okay, I try and see. Okay, A is 1, H is 0, and then K is 0. Okay, so this part, okay, x minus 0 is x, so it's x squared. Okay, times 1, so it's x squared. Okay, plus 0, so it's still x squared. So you see, okay, therefore for this fx equal to x squared actually means A equals to 1, H equals to 0, and K equals to 0. Okay, then you can compare with this A, B, and the C lah. Okay, I still have 6 more minutes. I don't know whether I can show you the graph or not. Okay, quickly we do. I need to go towards.
Teacher.
Yeah. Who is there?
Iris.
You are
Iris.
Iris. Why?
Iris.
What happened to you?
I'm so sorry, teacher. I set my alarm, but I didn't ring this morning. I don't know.
Okay, means you got to set more than 1 alarm already. It's okay, but you have to watch the recording, Then you have to do the homework, Okay, now Iris.
Okay, sure.
Okay, bye.
Bye.
Bye. Okay, so now I'm going to show you the example. If you have your textbook, I want to show you the difference in between the two graphs. For example, 14. I still only have 5 minutes. Okay, so this is another software that can draw graph. I always use this software lah. Okay, so first, oh, so complicated. Oh, I don't know whether I can type 2 plus x over 2. Okay, then plus 3. This is the first graph. Okay, I'm now doing A1, So A1 is changed to 6. So y equals to. This one change. One shot I compare to the 2. The second. Over 2. Okay, so I have a 3 graph. It will appear together. So cute. Okay, so you see the blue color one. Come on. Hey. Okay, they don't want to point. Come on. Okay, the blue color one is the original one, is the questions. Okay, with the A is 2. Okay, then when A change to 6, become thinner, so the red color one. Okay, this one is the A is 6. Then when A change to the half, become the width become white. Okay, so this is the A is half. Okay, so this is part A. Okay, I still got 3 more minutes. I show you the part B and the C. Okay, this one, the one. This one is what? I don't know. Can one shot? Wait, this is 2. Then this is 6. This is 6. Then this is 8. Okay, but here I want more. Okay, let us see. Okay, very good. Okay, so original one will be which one? Original one is this, the blue one. Okay, this is the original one. Okay, then for the for the part B, the graph shift to the left. So this is the part B questions. Okay, with the H changes to the -6, and then for the part C, okay, the graph move upward. Okay, so this is for the part C. Okay, where the K change to 8. Okay, so okay, that's all. Okay, I stop recording.